Hello guys, how are you today? I hope that you are all doing good and you are all safe. In our video today, we're going to talk about the third type of bonding, which is metallic bonding. Actually, guys, in this type of bonding, it is a little bit different than the previous types. It is not like covalent and ionic bond, because here we are talking about bonding between two atoms that have the same identity, which means we are talking about bonding between, for example, two sodium atoms together, or two potassium atoms together, or two copper, or two lithium or magnesium, or only metals. We are not talking about bonding between two different atoms like we used to do, like when we say, for example, that chlorine bonded to hydrogen with a covalent bond, or carbon bonded to oxygen with a covalent bond, or lithium bonding to fluorine with an ionic bond. Now, here we aren't talking about sharing or losing electrons. This is something else. And to understand the nature of metallic bond, we have to start with the sea of electrons concept. For example, if we talk about sodium, which is an E, you know, guys, that sodium contains one valence electron and it is located in the first group in the periodic table. So how does sodium atoms arranged together? Sodium is surrounded with another sodium atoms inside the crystal. And each one contains one valence electron, as you know. So what happened here actually is that electrons moved from the orbitals of the atom to be free to move around. So electrons will be everywhere around the sodium crystal, and it will be free to move. This is why we called it sea of electrons, because the electrons can move anywhere in the crystal. So electrons are free to move. This is why we called it sea of electrons. Now, when the electrons moved out, then the sodium atoms will be positively charged. So we have positive charge and negative charge around, which are the electrons. So the attraction between the atoms and the electrons that are free to move is called metallic bonding. So the chemical bonding that result from the attraction between metals and the surrounding sea of electrons is called metallic bonding. And actually, this sea of electrons is the main reason that give the metal its own properties. For example, metallic properties, as you know, metals considered as a very good conductors of both heat and electricity. So why they are good conductors? Actually, because the electrons are free to move, they can carry electricity or heat and move to another place. This is why it is able to conduct electricity or heat. Also, as you know, metals are both strong absorbers and reflectors of light. And this is also because they contain many orbitals separated by extremely small energy differences. Remember, guys, when we talked about exciting state and ground state, we said that when the electrons absorb energy, they will move to higher energy level. And at that case, we will have an excited state. And once the electron absorb the energy, they will fall down again to its original orbitals to go back to the ground state, and electrons will emit and release the same quantity of energy. This is what happened actually here in the metallic crystal. Because once electrons absorb the energy, they will move up to excited state, to higher energy level. And directly they will fall down again to its original orbital, so they will release the energy in a form of light. This is why they reflect light. And this is actually the responsibility, the main factor that is responsible for the metallic luster or metal surface. Why the metals are shiny? Because they are reflecting light. They will take light and reflect it again. So, CO of electrons is the main factor that give the metals its own and unique properties. Same thing also with malleability. We talked previously about malleability, and we knew that malleability is the ability of substance to be hammered or beaten into thin sheets. And ductility is the ability of a substance to be drawn, pulled, or extruded through a small opening to produce wires. Why they are malleable and ductile? Because same thing, existence of the sea of electrons. Because guys, if you have crystal of any type of metal and the electrons are surrounded here, when they be hammered, the electrons can move and change its place without being broken like non-metals. So we can change this crystal to wires or plates without affecting the property of the metal itself. This is why metals are malleable and ductile. And if we're going to talk about the strength of metallic bond, remember that here we cannot compare the metallic bond with the covalent and ionic bond. So we can't say that metallic bond is stronger or weaker than covalent or ionic bond. No, because in ionic and covalent bond, we are talking about bonding of two different atoms together, or at least like the covalent bond in molecules, two similar atoms like Cl2 and H2. But here we are talking about only bonding inside the metal itself. We can measure the strength of the metallic bond based on the enthalpy of vaporization, which is the amount of energy as heat required to vaporize the metal as a measure of strength. So, as the metallic bond increases, we will need more energy to vaporize 1 mole of this metal. As you can see here, it is actually depends on the number of valence electrons available to to form the sea of electrons. So as the number of valence electrons increases, that means that we will have more electrons and more negative charge available to make attraction with the positive atom inside, which means the strength of the bond will be increases. For example, if you see here, you can see lithium with one valence electron. The enthalpy of vaporization is 147 kilojoule per mole, while beryllium, which is contain two valence electrons, the heat of vaporization or enthalpy of vaporization is 297. If you go, for example, for the fourth period, potassium, which is also one valence electron, 77 kilojoule. Calcium contains two valence electrons, so the energy increases to 155, while Sc contains three valence electrons, so the amount of energy increases to 333. We are not going to talk deeply about the strength of the metallic bond, and this is the main point for it. And this is, guys, why actually in all of chemical equations we can write Na as individual atom. So we can see Na plus O2. We cannot say Na plus O for Na2O. We can't write the oxygen atom alone because it does not exist and non-stable in nature. While we can write sodium because sodium will be stable by attraction with another electrons from another atoms. This is why the metals could be written individually in chemical equations, while nonmetals like O, O2, H, H2, Cl2, F2, Br2, they are nonmetals, so they don't have a sea of electrons around them to make the crystal stable. This is why they have to form covalent bond here to be stable in nature, while metals can be stable without forming covalent bond and without being connected actually with another atom, so they will not form an A2. No need to have this bond here because the sea of electrons is responsible for gathering the positive atoms together in one crystal. This is all for this lesson. Thank you and be safe.